Lesson 6.6 is graphing systems of inequalities. So if you remember back to chapter 5, we graphed linear inequalities on a coordinate plane, but today's lesson is combining that with the systems of equations we did in the first lesson in this chapter. So it's just going to be like graphing that last inequality with two variables in the last chapter, but we're just going to graph two of them on the same coordinate plane today. So before we get started, a system of inequalities is a set of two or more inequalities with the same variables. Typically, we use x and y. So let's take a look at our first example. All right, so I am going to use two different colors today. I go ahead and use the pink. So my first one, just like last chapter, I'm going to put it a certain color, or if I'm not using two different colors, I'm going to put numbers beside them. That way we can keep all of our work nice, neat, and organized. I'm also going to look and say, okay, this is a less than, so that means my line is going to be dashed. I'm going to write it here because I know myself, I sometimes forget to actually make them dashed. So if I'm doing y equals 2x plus 2, the first step is already done for us. This equation is already in slope-intercept form. So I'm going to go in here, I'm just going to put the xy axis right in the middle. Again, you cannot forget to do that. We need to know where your graph is and how it's oriented. So you have to put an xy axis somewhere in your problem. So I'm going to start with my y-intercept. So I'm going to go up 2 units. I'm going to put a dot. And now I'm going to look at my slope. Now remember, my slope is rise over run. So that means any whole number can be written as a fraction by putting it over 1. So I'm going to go up 2 units to the right 1. I'm out of room, so now I need to go down 2 units, but I need to go to the left 1. Down to left 1, down to left 1. All right, and now this is a dashed line, if I can remember to do so. All right. So then we also, if you remember, since it is an inequality, we need to shade one side or the other. So I'm going to pick my test point of 0, 0, substitute that in. So y, or in this case, 0 is less than 2 times 0 plus 2. So 0 is less than 2. That is true. So I'm going to go ahead and shade the side that contains 0, 0. So in this case, it is this side. So I'm just going to shade this whole side here. All right, and if you don't wish to shade the whole side, you could just put lines down, or you could just and I'll show you one of the next ones. I'm just going to put little arrows to also show the shading. All right, so now let's go to our next problem. Hopefully we can see this blue. Yes. So that one, the second equation is going to be the blue color, and this is going to be a solid line. And again, it's already in the correct form. Now remember, to graph it, I'm just putting an equal sign there because typically when we solve the equations, we want it to be equal sign, remembering back to chapter 5. So our y-intercept is -3 this time, so 1, 2, 3. Now my slope is -1 over 1, so -1 down to the right 1 because it's positive then. I'll just show you, so if I do -1 over 1, that's how I'm getting it. Now I need to go up 1, which is positive, so then I need to go to the left 1. Remember, these should all make nice straight lines because these are linear inequalities. And this one I'm going to connect all the dots with a solid line. Now again, we have to pick a test point. So I'm going to use 0, 0. 0 is greater than or equal to -0 minus 3. So 0 is greater than or equal to -3. That is true. 0 is bigger than -3. We'll go with that blue color. So that means I need to shade the top side. All right, sorry, my shading is not the best, but my final solution to this system of inequalities is the area that is shaded by both. So I'm going to put it in like a little pentagon here since it has 5 sides. But remember, that space continues indefinitely in those directions. So what that means though, because this work here is just to get that double shaded region, what that means is any ordered pair that I pick in here, and I can pick any of them, that any of these points I pick, if I substitute those ordered pairs, the x value and the y value, into either inequality, they will both be true. And remember, that's what the solution is. It's values that make both of them true. If I pick something that's just in the red shaded area, it's not going to make the system true. It's only going to make one of them true. So we need that area that they are both true. Let's take a look at the second example. Go ahead, put my XY axis. I'm just going to put them all right in the middle. If they don't fit, well, then we'll figure out what to do. All right, first equation again is going to be this pinkish reddish color. This one is in slope-intercept form, so we can just go up 1, put a dot. Now, ooh, that's not really 1. My slope is -3, so 1, 2, 3 to the right 1. 1, 2, 3 to the right 1. And now I need to go up 3, but then I need to go back 1. So the one thing, oh, and I didn't write, but this is a solid line. Please make sure if your slope is negative, your line is going down from left to right. If I had to, and you guys know me, if I could think of aspects about your work that you've been turning in or even previous classes, that's one of the major things. Please make sure if the slope is negative, your line is going down from left to right. All right, now to pick a test point. It does not go through 0, 0. It's close, but it doesn't go through it, so we can still choose that. So this says 0 is greater than or equal to -3 times 0 plus 1. So 0 is greater than -3 times 0 is 0, plus 1 is 1. Is 0 bigger than 1? Well, that is false. All right, so I'm not going to shade the side that contains 0, 0. I'm going to shade the other side, and I told you I would show you the other way. So you are more than welcome to shade all of that. If you prefer that double shaded region, that's fine. I'm just going to show you another way. All right, so that tells me everything to the right should be shaded. Let's go to the second equation or inequality. Again, this is also solid, but this inequality, which I'm going to write as an equation, it is not in the right form. So we need to make it that way. So I'm going to subtract 3x from both sides. So I get -3x minus 2. All right, so now I can graph this. My y-intercept is -2. My slope is -3 over 1, so down 3 over 1, up 3, back 1, up 3, back 1. Now, if you notice, my two lines are parallel, which you may have noticed all the way back here since they have the same slope. For systems of inequalities, we cannot automatically say that it is no solution. Okay, because remember, it's the shaded region, so we need to see where this is going to be shaded. If it's going to be shaded the same direction as the other one, we will have points that will make both of them true. So let's test. Now 0, 0 is on the other side, so let's test our 0, 0, and we need to substitute it back into the original. So we get 3 times 0 plus 0 is less than or equal to -2. I get 0 plus 0, which is 0. Is 0 less than -2? It is not. So now that means this side would be shaded. Now, if you notice, do our shaded regions overlap? If you look at this problem, you'll say, nope, they do not overlap at all. And since those shaded regions do not overlap, we now can say this is no solution. Okay, I'm just going to put little sketches here. If we had two parallel lines, one option is that a solution, let me get a different color, is that they could be shaded in the middle. And then we would have a solution. That means my line to the right was shaded this direction, and the line on the left was shaded this direction, so the place where they overlapped was that whole middle region. So we can't automatically say with system of inequalities that if we get parallel lines, we cannot say that is automatically no solution. You have to continue shading and see which pieces and where those lines should be shaded. So since it is like that, I'm just going to go ahead and shade these in so that way it's a little bit more clear as to what our solution is. All right, so that's no solution. So take a few minutes, pause the video, and try those two. I believe there's 2 your turns. Okay, hopefully I gave you enough time there to work on it. All right, so for this problem, you'll be able to see that it's shaded between these 2 lines. So that means my solution region is everything in the middle there. Okay. On to part B. All right, so for this problem, we cannot choose the ordered pair 0, 0 because our line goes through that. So I'm going to pick any other point. I'm going to pick 1, 1. And 1, 1 was to the right there. So that means I need to shade the other side because 1 is not bigger than 4. All right, I can pick 0, 0 for this one. So So 0 is not less than -3. So that means that one's shaded to the right. So again, these two inequalities have no ordered pairs in common. So therefore, our answer is no solution. Because if I were to shade this, and I'll go ahead and shade it. The blue side shaded over here. Come on, there we go. The pink side is shaded to the left, so there's no overlapping regions for that shaded area. All right, so example 2 is going to take us into a word problem. So it says, a college service organization requires that its members maintain at least a 3.0 GPA, grade point average, and volunteer at least 10 hours a week. We have to graph these requirements. Now, thinking about volunteer hours and GPA, the lowest you can have of either of those is 0. So I'm going to put my XY axis along the left and along the bottom because I only need to see my first quadrant where everything is positive. All right, and I'm going to say, I guess in this case, it doesn't really make a difference as to which you choose X, which you choose Y. If you do flip-flop them from what I have, it might look slightly different, but the same values, like the same ordered pairs will work. So since grade point average comes first, I'm going to say that X is representing my GPA. Okay, so that means it must be at least a 3.0. So that must mean that X has to be greater than or equal to 3. Okay, so it has to be at least a 3.0 GPA. Could be higher. We don't want it to be any less. And then we're going to say that Y is our volunteer hours each week. So it says you have to volunteer at least 10 hours a week. So you could volunteer more, you could volunteer exactly 10, but no less than 10. All right, so let's go ahead and get this scale done. Because since I see 10, let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I go scale by ones, I'm not even going to see that shaded part. So I'm going to do by twos. So every line's going to be 2. So there's 2, 4, 6, 8, 10, 12, 14, 16, 18. All right, and same on here. Okay, so let's go ahead and I'm going to do our X one. So it says greater than or equal to 3. So go to where X is 3. So 3 is going to be right in here. And that means every X value is going to be 3. So remember, when X is equal to a number, it's a vertical line. So I'm going to put, and remember it's solid because there's equal to there. So I'm going to put a solid line straight. Oh, that's actually not too bad. Now, which way will it be shaded? Well, it will be shaded to the right. It will be shaded to the right because those are all the values that's greater. So it's going to be shaded this way. And I'm just going to go ahead and shade everything. Okay, so now let's take a look at our community service hours. Well, that says Y is greater than or equal to 10. So on that vertical axis right there is where Y is 10. And that means all of my Y values are going to be 10. So no matter where I go on my X axis, I'm always going to be going up 10. So again, that's a solid line. And now where are the Y values bigger than 10? Are they bigger below that line or are they bigger above that line? Well, they are all bigger above that line. So now I'm going to shade everything above that pink line. So the students, if they want to fit into both of these categories, they have to be in that double shaded region, which is a little bit tricky to see because these highlighters just highlight over one another. So I'm going to take a third color and highlight just that solution region. So the kids who fall in that double highlighted region, or in this case in this yellow area, those are the students that would fall into that service that the organization is requiring. Right, so pause the video, take a moment, try that last your turn, and then come back and double check your work. Okay, again, you can't be a negative number of years old, and you can't weigh a negative number of pounds. It's either 0 or something higher. And you know what, I think even going by tens, I'm going to go back and erase all of those, and I'm going to do this maybe by 20s to make it fit better. So see, guys, you just have to try it out and see what works. So I'm going to say this 20, 40, 60, 80. There, I think that's better. 100, 110, 120. Okay. So now 17 is going to be about here-ish. Everything's going to be shaded to the right because they have to be older than 17. And then greater than or equal to 110 pounds. So that's here, and it is a solid line. Let me make it a little thicker. And that's going to be shaded up. So therefore you can see the double shaded region. It's going to be right there. And again, it will continue up and to the right. All right, so take a moment, make sure you understand this, and then go ahead and start your practice.